Special theory of relativity. This is very interesting topic for all the students, where one has to use their visualization to observe a particular phenomena. So Einstein was the person who basically published a research paper in 1905 related to the special theory of relativity. As you know that this theory of relativity depends on the relative motion, a relative motion between two observers. Here in this video section I will be discuss 2 points. One is the observer and second is the frame, reference frame. How most of the students thinks about the observer's reference frame and the event. So I will discuss all these points systematically. Mathematically, we basically present the physical situation in terms of the reference frame. You understand this statement, right? So here these coordinate system x, y, z, which is denoted by the s prime, and here x prime, y prime and z prime, that is denoted by s prime prime, are basically nothing except to the representation of the physical situations. I will show it in next slide, but before that you have to take this point that this is only the mathematical representation. V is the relative velocity with respect to the observer O. This is also true with respect to the S also, but in general if we go little bit in depth, then you will realize that actually this relative velocity is with respect to the observer O, and this is the moving frame S prime in which O prime observer is sitting. Now the next point comes for event. What is an event? Actually anything which can be observables, that is the event. And event we define in terms of the coordinates. Like in case of O prime, if suppose an event, we use this scientific statement in our syllabus, our course, that an event occur at the point P, right? So what is that event? Event may be any, so event may be an explosion, event may be whatever basically you can observe or can tell anyone in terms of the place and time. Now the point is, if O prime observer who is sitting in a moving frame observe that event, he will define that event in his coordinates, and they are x prime, y prime, z prime, and the time coordinates t prime. This event happens into the moving frame, and that frame is s prime. This s prime is a moving frame, and here an event occur which is observed by this observer O, who is in rest in s frame, will measure this event in his coordinates x, y, z and t. So this is the first statement which we use in relativity, and second point comes about the event. After making it clear that what is S, what is O, what is S prime and O prime, and simple S and S prime are reference frames only. That may be a tree, that may be a car, train, spacecraft, surface of the earth, a room, a classroom, wherever you can basically observe the event, that may be a reference frame. So here the next point, you are the person basically, O is that person who observed the event into the frame. So the main game is of the O. Here S is inertial or non-inertial, that is the point. In special theory of relativity, S and S prime must be inertial. This is the condition, so no one can change it. But O and O prime observe the events, they are main important factors in the special theory of relativity, and they are nothing, they are real observers. So I will show that this mathematical representation in correlation with the real physical situation. So second point comes for the event. Event, as I told you, may be anything, and who is basically observing that, and from where, this is also important. O observer observe the event in his frame of reference. O prime observe the event in his frame of reference. So the observation of the O and O prime will define in his coordinate system. So all these language, all these statements which you have listened right now are mathematical representation of the physical situations. So we use these words. Now we will see physically what is happening. So here in this S and S prime frame, if you don't see the lower one picture, then what basically these S and S prime frames represent? Yes, I have just tried to explain here. The man on the surface of the earth, a spacecraft in the sky. So there are two things. So I have to create this physical situation in a mathematical form. How I will basically create this situation, that is in terms of the frame of references. Here S frame denotes the surface of the earth. O denotes the man. This S prime frame, which is moving with velocity v relative to the S, is a spacecraft. Or you can say that this spacecraft is moving relative to the observer O, right, the velocity v. So what is S prime? S prime is a spacecraft and O prime is the pilot. I hope now this point is clear. This is the physical situation. I have to represent this physical situation in the mathematical form that is defined in terms the coordinate system, that represented by the coordinate system. Here we were saying S is the frame, a reference frame for the observer O. What is that? That is the surface of the earth, or reference may be anything, as I told you, a car, a train, a bus, a floor, whatever you can assume from where you can observe the event. That is the frame basically, and here this is the observer, right? So this representation for this one, this physical situation. And the second one, this here S prime basically is representation of the spacecraft, and v is the relative velocity, that is the velocity of the spacecraft, and O prime is the observers, and right now that is the pilot. So I hope I have made it clear. If anything happens into the moving frame, S prime is a moving frame, that is the spacecraft. If suppose a bomb explode into the spacecraft, and the event, this is the event, and this event is observed by the observer O prime. So he will define that someone, this bomb explode into the spacecraft at this place at this time. So that is basically event which we define or denote with the help of symbol P. So P is basically nothing except to the information of place and the time. Right. Now this place and time is telling O prime observer. And who is that? O prime observer is the pilot, right? And that is in moving frame, that means that is in spacecraft. Now such same event, if suppose is observed by the observer O, it means this man has seen the event and he will define this event in his frame of reference. That means he will tell this event happens at this place and at this time. So this is the observation of O. So here he will tell the event in his coordinate system, that is x, y, z and t. So the pilot will say that this event occur at this place and at this time in his coordinate system, and mathematically they are x prime, y prime, z prime and t prime. Similarly, this man who is on the surface of earth will define this event according to the place and time. He will say that this event occur at this place at this time. In mathematically, if we have to represent that this event, we will define it in x, y, z and t form in unprimed frame. So this is one of the important point. One more situation you can see here, that this is the reference frame S and this is S prime frame. Car A is moving now with some constant speed, and that you can say 40 km per hour. And here B is moving with 80 km per hour. So this velocity, this speed of the car, that is 40 km per hour, is constant. There is no acceleration, so this will treated as a inertial frame, and that frame we represent here with the S frame, and the driver of this car A is O, right? That representation is by O. Here the second car, that is B, is represented by S prime moving in positive x direction. For an example, right now with the relative velocity 80 km per hour with respect to the first one, that is denoted by S here. O prime is the driver of this car. So if you see, these representation of the coordinate system are nothing except to the physical situations. If you can visualize the physical situation along with the reference frame, then there is no problem. And event is defined according to the O and O prime. If suppose O prime, I have given this example into the earlier video lecture also. When you were child, you have observed that train. That times when you were child, you observed that trees, plants are moving in opposite direction. That observation at that time was correct. There was no any single doubt into that. But now when you are aware that trees are stable, they are not moving, that is the different point. But that time that tree, plants and other objects are moving in opposite direction with the same speed as of your train, right? So this train is equivalent to the S prime frame if the speed of the train is constant, there is no acceleration, right? And you are the observer O prime. The man, if suppose is standing on the surface of the earth, he will observe that there is no motion into the tree and only train is moving. So there are number of physical situations which you can correlate with the S and S prime. So here this S and S prime are nothing except to the coordinate system that represents the physical situation, real physical situation mathematically. Now here I want to tell one more important point. When you read Galilean transformation and Lorentz transformation, I want to tell you one more important point. When you see the transformation of equations like Galilean transformation, Lorentz transformation, what basically you observe that you are getting this information. You know that transformation means that we are converting one coordinate system into the other, and these equations are nothing except to the representation of the place and time. So first of all, I make it clear that if suppose an event occur into the S prime frame, that is the moving frame S prime, right, that event actually observed by O prime in his frame of reference. So how it will appear from the O point of view, right? So we have to find out basically that observation, how it appears to the observer O. So we use these transformation equations, so Galilean transformation and Lorentz transformation. Actually, if I tell you that this event I will define if I am in rest frame according to my coordinate system, and that is of the unprimed frame. If I have to observe the same event from the O prime observer points of view, then I will use these prime frame equations, right? So these equations are just for that purpose. Remember this one. This is very important point. X prime, y prime, z prime, t prime. When you are writing these equations, for what purpose? For O prime observe the event in his frame of references in a proper way. That was true. But O is in rest. He observed the event from his frame of reference, but O wants to see that event according as of O prime. So he will use his coordinates x prime, y prime, z prime and t prime. How? Galilean gives these equations because x and t are the coordinates of the observer O. He can use their observation, and with the help of that he can define the coordinates of the O prime, and by using these coordinates he can define that particular event. You got my point? What I am saying? I am saying that I am in rest frame and I observe that event into the moving frame with the help of my coordinate system. I know that coordinates actually. I know the relative velocity of the S prime frame. So by using these coordinates and relative velocity, I can define the coordinates of the O prime observer. And by those coordinates, I can visualize, I can observe the event in a same way, in a same fashion as O prime observer have seen. I hope I have made it clear. So we use the Lorentz transformation or Galilean transformation equation in that way into the S prime frame that is observed by the O prime observer in his frame of reference with the help of x prime, y prime, z prime and t prime. But this event from the O point of view, then he will use these x prime, y prime, z prime and t prime. How? With the help of their coordinates, by using these transformation equations. This is the only idea related to the reference frame in special theory of relativity. If you have any doubt, any question, you can just message me just below this. If this idea, if this explanation is helpful to you, because I can understand the complexity of the concept, but if this idea, if this explanation is helpful to you, please like, share, subscribe this video. Thanks for watching, for giving this much time. Thanks once again. Please like, share and subscribe.